All right, welcome back for part two. As always, I've got my email address up at the top in the YouTube channel. I'm just going to dive right into part two of our vocabulary and examples. So we left off with an expression. Let me zoom in a little bit here. So expression, it's just a combination of values and operations that represent a collective value, but it does not include an equal sign or an inequality, and that's really the key point there. It does not include the equal sign, does not include the inequality. So there's nothing really to solve at that case. So my example I'm going to use right here, 5x plus 7, that's an expression. You can evaluate expressions, but you can't do anything in terms of solving for x, because again, there's no equal sign or inequality. So that's just an example. Expressions can be multiple terms. They just can't be an equal sign or an inequality sign. An equation does have an equal sign. It's a statement that shows two or more equal mathematical expressions. So, for example, there we go. It's got an equal sign. In this case, we're able to solve for the missing variable. So, divide both sides by 2. We'll get more into that. But you can actually solve for an x value in that case. An inequality is similar to an equation, but the two expressions are going to be unequal, or they could be equal. We'll get more into that when we actually cover inequalities. It could be less than, greater than, less than, equal to, greater than, or equal to. So using the same exact the equation from before, I'm just going to change the sign to an inequality sign. 2x plus 6 is less than or equal to 10. You could solve that pretty much the same way. There's a few different rules that you don't have to worry about so much about with an equation. Divide both sides by 2. X is now less than or equal to 2. That's the main difference when you're solving an inequality, is that your solution is going to be a range of values. So in this case, x is anything that is less than or equal to 2. We'll get more in depth into that when I get to that video. Simplifying is, again, just something you can do to an expression to make it a little bit less complex or more concise. You can combine like terms, you can reduce fractions, all that kind of good stuff. So for example, if I have 3x plus 5x plus 8, 3x and 5x are like terms. Remember, they have the same variable, same exponent. So I can add, in this case, their coefficients together. 3 plus 5 is 8x. So that makes it a little bit easier to deal with. You can also reduce fractions. We'll, again, get into that more when we cover that specific example. But, if I have something like 4 plus 6 over 2, 4 plus 6 is 10, and then 10 over 2 is 5. So you can always reduce, or you can make things simpler. Evaluating. You are finding the numerical value of an expression when you're given a value for that variable. So for example, I have 3y minus 2, and we're going to evaluate this if y is equal to 4, for example. So what I have to do is evaluate. I have to substitute in 4 for the variable, and then I have to follow the order of operations. Again, we'll get into that a little bit more, but in this case, the multiplication comes first. 3 times 4 is equal to 12, and then we bring over the minus 2, and then we go ahead and get to our final step. 12 minus 2 is 10. That's evaluation. We're plugging in a value. Solving is when you find the value or values of one or more variables in an equation that make that equation true. I kind of already gave you an example up above when I went over what an equation was. I actually went ahead and solved it, so that sort of covers that. But again, I'm trying to make up an example off the top of my head that'll work out evenly, but that's okay. I'm just going to make one up. It doesn't have to actually work out evenly. Again, very simple example, but I'm going to go ahead and solve. I have to have an equation or an inequality in order to solve that. I didn't put that in the definition. 3x equals 5. Divide both sides by 3 to get x by itself. So this one didn't have a nice integer solution, but that's okay. Sometimes that happens. I went ahead, got a little bit ahead of myself here, because this is one that, I'll see this a lot. in instructions, but a lot of my students in the past have not been able to tell me what a function is. And it's important that we understand what that is. It's a relationship between two variables, generally called the input and the output, also referred to as the independent or dependent variable, that's respective. So generally, the input is going to be x, the independent variable is going to be x, and the output or the dependent variable is going to be y, generally, when we're talking about, a graph. That could be anything, but, that's kind of the default. But it can be expressed as a written phrase, an equation, a table of values, or as a graph. So I'm going to do the same function in all those four ways just to give you an idea. So the written phrase I have here, the output is twice the input. So twice means 2 times. I'm multiplying by 2. It's a very simple equation here, very simple function, but that's the written phrase. An equation would look like the output, y, is equals twice the input, 2 times the input, or 2 times x. Okay, so it's a very quick example, but y equals 2x, pretty simple, in this case, linear function. We'll get into what that means later. Table of values means I'm going to have my input and my output, my x and my y values in a table. Could look a couple different ways. This is the T table is a pretty common one. I'm just going to use 5 values that kind of hover right around 0. Kind of keep it close to the origin of the graph here. So if I say y equals 2x, I'm going to substitute each of these values of x in. Basically, I'm just multiplying everything by 2 to get my y value. So negative 2 times 2 is negative 4. Negative 1 times 2 is negative 2. 0 times 2 is 2. 1 times 2, I'm sorry. I lied to you. I got ahead of myself. 0 times 2 is 0. 1 times 2 is 2. And then 2 times 2 is 4. See, even the best of us can make mistakes when we rush. And then as a graph, we would take that table of values and plot those points on the graph. If you're not sure what I'm doing right now, no big deal. We are going to get to graphing. But I'm just going to make a quick graph. This is not very neat, but it is what it is at this moment. So there's my y-axis, there's my x-axis. So I'm going to plot those points. So negative 2, negative 4 is over here. Negative 1, negative 2. Then 0, 0. And then 1, 2. And then 2, 4. So those are my points. In this case, it is linear. I could have told you that before we even started because the exponent on x is understood to be 1. Different degrees, different powers are going to give us different shaped graphs. So we'll get into that, again, a lot more later. But that's just an example of the same function in a couple of different ways. So moving right along here, a ratio. It's a comparison of 2 or more values. So I sort of had an example already figured out here. I'm just going to say that out at the park, for every 3 boys at the park, there are 2 girls. So I'm comparing these 2 values. And a ratio can be written in a couple different ways. It can be written separated by a colon, where I'm comparing the 2 parts. So if I wanted to compare the ratio of boys to girls, I would just have to put a colon between those values. So for every 3 boys, there are 2 girls. So the boy to girl ratio is 3 to 2. And if you wanted to flip the order, you could always flip the order and say girls to boys, which would be 2 to 3. So that's a common way you're going to see ratios. Another way is by a fraction, which represents parts to whole, or to the total, I should say. Would probably be a better way to put this. Pardon the handwriting, it's on a screen. So if I wanted to say, okay, what fraction of the population of the park is boys, I would say, well, from this group, or for every so many people, there are 3 boys. That's the part I'm looking at, is how many boys there are. Out of how many total, 3 plus 2 is 5. So 3/5 of the population at that park are boys. And that would work for, you could extrapolate that to bigger numbers. It doesn't have to be just out of 5 people. There could be any multiple of 5 people, and we would still be able to tell how many boys there would be just by using that proportion, that fraction, 3 over 5. So those are a couple of different ways that ratios are expressed. They're also expressed as percentages sometimes, which again we'll get to. In this case, 3/5 you would just change into a percentage, which in this case is 60%. That's the ratio of boys, 60%. So just a different way of showing what portion there are there. Fractions, I kind of already got into that. You probably know what they are anyway. Fractions represent, or a fraction represents the parts of a whole or division of one value by another. Again, if I have 6 blue marbles and 3 red marbles in a bag, okay, and I said how many, what fraction or what portion are blue? Well, again, a fraction shows what part you're looking at compared to the total. So if I want to know how many blue there are, I'm going to go how many are blue over the total. Well, that's going to be 6 over the total, 6 plus 3, 9. And then I can always reduce this fraction by dividing the top and the bottom, the numerator and denominator, by the same value. Again, I'll get into how to do this, but I know the greatest common factor is 3. So 3 over 3, which is really just a 1 in disguise. You can divide by 1 and not change the value. 6 divided by 3 is 2. 9 divided by 3 is 3. So we've reduced the fraction. So 2/3 of the marbles are blue. A proportion is a statement of equality between two or more fractions or ratios. I'm sort of getting ahead of myself on this video a lot. That's a proportion right there. 6/9 is equal to 2/3. It's a statement of equality. Okay, they are the same portion. Another way that we can use proportions, though, is to solve equations. Anytime that we have a set of equal fractions, or ratios in this case, we could set them up as ratios, and we know that they're equal, so there's a certain way that we solve proportions. One fraction equal to another fraction means that you can cross multiply and solve. So for example, if I wanted to know, we'll go with 2/3 again. 2/3 is equal to what out of 18? We could figure out what numerator would need to be, what that numerator would need to be in order to make this equal. Okay, so a couple different ways to do this. We could either cross multiply and get rid of the fractions and solve that way, or we could even just go, hey, 3 times or divided by what gives me 18, and do the same thing up top. 2 times 6 is 12. That's one way to deal with proportions. The other way I'll show you is just to cross multiply. So we'll do the exact same thing. 2/3 equals x over 18. We can cross multiply. X times 3 is 3x. 2 times 18 is 36. I'll bring this up here. 3x equals 36. We divide both sides by 3, and we get x equals 12. I'm doing this all very quickly, just in case you already have some familiarity, but we'll get more in depth when we go to these actual videos. Couple more definitions. Again, I didn't cover every definition of the book just because we'd be here all day, but coordinates are ordered pairs. It's a set of values represented x comma y in parentheses that are used to express the exact location on a coordinate plane. So coordinate plane, two-dimensional. X value is how many spaces you're moving from the origin, from the very center of the graph where the x and y axes cross. Whether you're going left or right is going to determine if that number is positive or negative. And the y value is how many spaces you're moving up or down. Again, positive or negative will tell you if you're moving up or down. So it's all about direction here. So positive x and positive y are going to be right and up, respectively. A negative x value and a negative y value are going to be left and down, again, respectively. So if I wanted to plot the point 3, negative 2, well, the x value is positive 3, so I'm going to go 1, 2, 3 to the right of the origin, and the y value is negative 2, so I'm going to go 1, 2 down, so right 3, and then down 2, there it is, 3, negative 2. Okay, there's going to be different quadrants. Okay, quadrant 1, quadrant 2, quadrant 3, and this is quadrant 4, indicated by Roman numerals. We'll get more in depth later. Last one for this video, factorial represents the product of all non-negative numbers, integers, less than or equal to a given positive number. You're going to see an exclamation point. 5 factorial just is 5 times 4 times 3 times 2 times 1. Okay? And then you're going to multiply that out. That's going to be 624 times 5. I am running out of time, so figure it out yourself.